Making predictions. Regression equations are often useful for predicting the value of one variable given some specific value of the other variable. When making predictions, we should consider the following. Number 1, bad model. If the regression equation does not appear to be useful for making predictions, don't use the regression equation for making predictions. For bad models, the best predicted value of the variable is simply its sample mean. Number 2, a good model. Use the regression equation for predictions only if the graph, the regression line on the scatter plot, confirms that the regression line fits the points reasonably well. Number 3, correlation. Use the regression equation for predictions only if the linear correlation coefficient R indicates that there is a linear correlation between the two variables. 4, scope. Use the regression line for predictions only if the data do not go much beyond the scope of the available sample data. The figure below to the right is going to summarize a strategy for predicting values of a variable y when given some value of x. Okay, so before we read the figure, it says it shows that if the regression equation is a good model, then we substitute the value of x into the regression equation to find the predicted value of y. However, if the regression equation is not a good model, the best predicted value of y is simply y, the mean of the y values. But if y is the best predicted value, it isn't very good because it is the predicted value of y for any value of x. Remember, this strategy applies to linear patterns of points in a scatter plot. If the scatter plot shows a pattern that is non-linear, not a straight line pattern, other methods apply. So let's take a look at the graph here. Strategy for predicting values of y. First question, is the regression equation a good model? Meaning the regression line graph in the scatter plot shows the line fits the points well. The linear correlation coefficient R indicates that there is a linear correlation, and the prediction is not much beyond the scope of the available sample data. If you answer all these questions and you say yes, then that equation, the regression equation, is a good model. So you would substitute the given value of x into the regression equation. Now, if you answered this question as a no, then you would say that the regression equation is not a good model. And regardless of the value of x, the best predicted value of y is going to be the value of the mean values of y. Again, that's the mean of the y values.